The 30, 60, 90-degree triangles are shown on the left is used to solve for the cosine and sine coordinates of all 30-degree and 60-degree reference angles in the unit circle. The reference angles of 30 degrees are shown in orange on the picture to the right, and the 60-degree reference angles are shown in green. So if we were to find the coordinates of the 30-degree triangle on the unit circle, the first thing we would do is solve for x. And so to solve for x, this would allow us to plug this in to x to find sine, and x times the square root of 3 to find cosine. And so the first thing we would do is we would take 2x equals 1. We would use 2x because the hypotenuse of the 30-degree, 60-degree, 90-degree triangle is 2x. And this would be equal to 1 because on the unit circle, the radius always equals 1. So now that we have 2x equals 1, we want to get x all by itself. And to do this, we would divide 2x by 2 and 1 by 2. So we would divide 2 by both sides. And after we divide 2 by both sides, our answer would be x equals 1/2. Now we have x equals 1/2 to plug in to find sine and cosine. Now that we have x equals 1/2, we can solve for sine, which is represented by x on this leg. On the diagram, the leg shows x, so we would take x equals 1/2 and plug 1/2 into x, and so sine would equal 1/2. And now that we have sine, we can also solve for cosine, which is represented by this leg down here, which is x times the square root of 3. We can take 1/2, which we had already solved for to find x, and we would plug in 1/2 into times the square root of 3. Now because it's 1/2 times the square root of 3, we can take the fraction and times that, and we would get the square root of 3 over 2, which our final answer would then be cosine equals the square root of 3 over 2. So the coordinates on the unit circle are cosine, sine. And so what our final answer would look like is the square root of 3 over 2 and 1/2. So the only difference between the 30-degree triangle and the 60-degree triangle is that the triangle has been flipped around. When we look at quadrant 1, we see that the first line, which are here, is the 30 degrees, which we just solved for. But when we solve for 60 degrees, that is up here, making the angle larger. The triangle is going to be flipped around because the 30 degrees is located at the center, which would be located right here. But if we solve for the 60 degrees, the angle in the center grows to 60 degrees, which would be up to here, instead of the small little green angle, which was the 30 degrees. And now the outer angle, which if we draw a triangle, would look something like this. The 30 degrees is now going to be located up here. So if we look at the triangle flipped around, we would remain with 2x as our hypotenuse. And instead of having the 60 degrees up here, it would now be 30 degrees. And instead of 30 degrees here, it's going to be 60 degrees. And so instead of having the x sign in between the 60 degrees and 90 degrees, it is now going to be x times the square root of 3, which is sine, and the leg in between 60 degrees and 90 degrees is going to be x, which is cosine. Even though the triangle flips around, x times the square root of 3 will always remain on the leg between 30 degrees and 90 degrees, which is right here. And the x will always remain on the leg that is in between the 60 degrees and 90 degrees. And so they will always stay in between these degrees but the only thing that changes is the sine and cosine, which flip around. When finding the coordinates for 60 degrees, we follow the same steps as when solving for 30 degrees. We first want to solve for x in order to plug that into x times the square root of 3 and x. To do this, we equal to x equals 1, since the radius of the unit circle always is 1. We divide 2 by both sides in order to get x all by itself, giving us x equals 1/2. Now we can plug 1/2 into x. To find cosine, we plug 1/2 into x, giving us cosine equals 1/2. To find sine, we plug 1/2 into x times the square root of 3, giving us 1/2 times the square root of 3. Because 1/2 is a fraction, we can multiply that by the square root of 3, giving us the square root of 3 over 2, which equals sine. So our final answer will look like this: 1/2 and the square root of 3 over 2.
So you can also use the 45-45-90 triangle to help find trig functions in the unit circle. So if you take the 45-degree angle, which is from here to here, you can find the sine and cosine of that. And then 45 degrees here, here, and here.
The second type of triangle in each quadrant of the unit circle is the 45-45-90 triangle. The hypotenuse of this triangle is equivalent to the radius of the unit circle, which is always 1. So we're going to have a square root 2 equal to 1. In order to find the coordinates of this triangle on the unit circle, you have to solve for a. First step is to divide each side by square root 2. Once you've done this, a is going to equal 1 over the square root of 2. The next step is to multiply 1 over square root 2 by root 2 over root 2. Once you've done this, your answer is going to be root 2 over 2. In the unit circle, cosine is x and sine is y. Because both the cosine and sine of this triangle are equivalent, the coordinates are going to be root 2 over 2 and root 2 over 2 for both. For quadrant 1 on the unit circle, your 45-45-90 triangle is going to have a coordinate of root 2 over 2, root 2 over 2.
So if you take the sine and cosine of the 45, 30, 60, and 90 triangles, you can also find the tangent, cotangent, secant, and cosecant. So tangent is sine over cosine, cotangent is cosine over sine, secant is 1 over cosine, and cosecant is 1 over sine.